The state's historical power rests on controlling the means of violence, specifically the industrial production and distribution of arms. This foundational monopoly is dissolving due to additive manufacturing technology. Digital blueprints, not factories, now define access to firearms. A single file, easily shared globally, renders centralized licensing and supply chain controls obsolete. This technological shift fundamentally alters the power asymmetry between the governed and the government. The ability to fabricate complex mechanisms locally, on demand, bypasses all traditional regulatory chokepoints designed to restrict individual armament. This decentralization of production is the most significant challenge to state authority since the invention of the printing press. Additive manufacturing, commonly known as 3D printing, transforms digital data into physical objects layer by layer. This process requires only raw polymer filament and a desktop machine, costing less than $1,000. The crucial element is the digital blueprint, typically a computer-aided design or CAD file. These files are non-physical and subject only to information law, not traditional arms regulation. The FOSSCAD movement, free open-source software and computer-aided design, actively develops and distributes these blueprints globally. This network operates without central leadership, making it immune to takedown orders or seizure. The designs are constantly iterated and improved by a global community, ensuring resilience and rapid technological advancement outside institutional control. Current legal frameworks are designed to regulate physical objects, requiring serial numbers, background checks, and licensed manufacturers. These laws fail entirely when applied to digital information. Attempting to regulate a CAD file is equivalent to regulating speech, protected under many constitutional frameworks. The U.S. State Department attempted to block the distribution of these files under International Traffic in Arms Regulation, ITAR, but this effort was defeated in court, establishing that the files are protected speech. Even if one jurisdiction bans the files, they instantly proliferate across peer-to-peer networks in jurisdictions that uphold free speech principles. This legal and technological reality ensures that the knowledge required for decentralized arms production cannot be suppressed. From an anarchist perspective, the widespread, untraceable availability of arms acts as a powerful deterrent against state overreach. If the cost of enforcing arbitrary laws or initiating disarmament campaigns becomes prohibitively high due to ubiquitous individual armament, the state is incentivized toward non-aggression. This concept is known as deterrence via decentralization. Unlike nuclear deterrence, which relies on massive centralized power, this model relies on the impossibility of identifying and neutralizing millions of individual production nodes. The state cannot effectively disarm a population that can regenerate its means of defense instantly and locally. This shifts the security calculus from reliance on state protection to individual self-sovereignty. Defensive autonomy is the principle that individuals possess the inherent right and capacity to defend their life, liberty, and property without relying on external authorities. 3D printed arms provide the physical means to realize this autonomy. This aligns directly with the non-aggression principle, or NAP, a core tenet of anarcho-capitalism, which prohibits the initiation of force or the threat of force against others. When individuals are equally capable of defense, the incentive structure favors peaceful interaction and voluntary exchange over coercion. The technology ensures that the individual is never entirely dependent on a centralized security provider, mitigating the risk of that provider becoming the aggressor.
Traditional arms manufacturing requires complex, globalized supply chains involving specialized machinery, metallurgy, and large-scale industrial infrastructure. These chains are easily monitored, regulated, and disrupted by state actors. Decentralized additive manufacturing drastically simplifies this requirement. The necessary components are reduced primarily to polymer filament, readily available globally for non-military applications and standard hardware store parts. This resilience means that even in scenarios of economic collapse, war, or severe state repression, the capacity for self-defense production remains intact at the household level. This localized production capability is a critical factor in maintaining individual liberty during systemic crises. The distribution of 3D printable arms blueprints leverages cryptographic technologies to ensure immunity from censorship. Files are often shared using decentralized storage networks like IPFS, the Interplanetary File System, or embedded directly into blockchain transactions. Once a file is uploaded to IPFS, it is replicated across thousands of nodes globally and cannot be deleted by any single entity. Furthermore, using encrypted channels and Tor networks obscures the identity and location of both the distributor and the recipient. This cryptographic resilience guarantees the perpetual availability of the knowledge, regardless of governmental attempts to filter or block access points. The information itself becomes a permanent, unregulatable public good. Early 3D printed designs relied heavily on basic polymers, limiting durability and caliber. However, advancements in material science are rapidly expanding capabilities. High-strength carbon fiber reinforced polymers and specialized nylon composites now allow for the fabrication of components capable of handling significant stress and heat. Furthermore, desktop metal printing technology is becoming increasingly accessible, promising the ability to fabricate critical components like barrels and receivers from durable alloys outside of industrial settings. This technological trajectory suggests that within the next decade, the performance gap between commercially manufactured and individually fabricated arms will virtually disappear, further solidifying decentralized deterrence. State responses typically focus on banning the files, banning the printers, or banning the raw materials. Banning the files is ineffective due to cryptographic distribution. Banning the printers is impractical, as these machines are essential tools for countless legitimate industries, from dentistry to aerospace prototyping. Attempting to control polymer filament is equally futile, as it is a ubiquitous industrial material. Some jurisdictions have attempted to mandate kill switches or tracking chips in 3D printers, but open-source firmware allows users to easily bypass these restrictions. The state is left attempting to regulate information and general-purpose tools, a battle it cannot win against decentralized technological proliferation. The convergence of additive manufacturing, open-source design, and cryptographic distribution creates an irreversible shift in the balance of power. The ability to produce arms locally and autonomously ensures that the individual retains the ultimate means of self-defense, independent of state permission. This technological empowerment is a practical realization of anarchist ideals, moving beyond theoretical arguments to establish a physical barrier against coercion. Decentralized arms production guarantees that the state can never fully reclaim its monopoly on force, establishing a permanent, technologically enforced check on governmental power. This is the new reality of individual sovereignty in the digital age.